we're sort of going to do like the formula sheet for the double quiz right now as we review for this, as we review this stuff. Guys, starting. Okay. So let's kind of review. Can anybody tell me any probability formula or idea we discussed last time? It's a little vague, I know, but
The line meaning given.
beautiful. Okay, so let's go there. So how do you read this?
Probability of any given B.
Sweet. That means given, right? This is not paid. I like it. Does anyone remember what the formula for this was?
Probability of A divided by
I like it. What's the, so that's awesome. It kicks so much ass. There's more formulas we'll get to in a minute, but what's the basic idea of probability? And I kind of told you guys, every single damn formula that we see comes from this basic idea. Do you remember we did a whole bunch of problems and I had not even given you a damn formula at all? Do you guys remember that from the other day? I just put up all these numbers in this chart and we just chugged all these frickin' probabilities out left and right. And then I went, oh yeah, let's make some formulas. Maybe that'll be nice. That's because if I give you everything you need to count, that's all probabilities are based on. Probabilities are based on counts, right? So if I give you everything you need to count, you don't need any frickin' formulas. Am I always going to give you everything you need to count? No, nope. So sometimes you will need a formula. So one thing I want to do today, and I think I'm going to do it after you guys work on the worksheet, because it kind of confused people earlier when I did it before. I want to show you an example of a problem that you must use the formula for. There's no other way to do it. So we'll do that after the worksheet. Can somebody give me another formula we came up with? Somebody else. Sorry, man.
probability of A or B.
A or B? A or?
There's probability of A added by probability of B subtracted by probability of A and B.
Kick ass. Yeah. Well, that's powerful. Damn. Feeling pretty good. Is that cool? So again, or is basically add. Because if I have people meet requirements and they're separated by ors, they don't have to meet all of them. They just have to meet at least one of them. So that increases the number of people that would actually get in. So I'm thinking about that. I told you guys about the nice bouncer and the evil bouncer. Yes, okay. On that note, what's the formula for probably A and B?
PB times P A given B.
And then there's another way to see it.
A times.
All right. So real quick, that is, you could, if you wrote all these things down on a clean sheet of paper, that could be your formula sheet for the double quiz next Wednesday. You guys would pick. Okay, so I want to point out a couple things. In a perfect world, the probability of A or B would just be this. Wouldn't that be awesome? Then or would mean add, just period. Not basically add, the way I have to say it. In a perfect world, and would just be this. Just multiply the two things together. Yes? You guys kind of with me? Does that sort of make, wouldn't it be nicer? Wouldn't it be easier to remember? And of course it would be wrong. Everything we do would be shit. But this would be nice. This is true sometimes. What is this missing from the actual formula?
Subtracted by.
Yes, the adjustment we have to make. When is this not needed? When it's equal to 0. When is this equal to 0? If A and B are mutually exclusive. Yes, when they're mutually exclusive. You guys with me? So in a certain situation, or really is just add, but it's only in that specific situation. If they don't share anything, then I don't have to subtract anything. I like it. So this is only true if they're mutually exclusive. Bless you.
Thank you.
Now, when is this true? When is the probability of B given A equal to the probability of B? Shit. So let's really analyze that for a second. Probability of B given A equal the probability of B. What would that mean? That would mean that A happens. Does the probability of B change? A happens, and the probability of B, does it change? No. So what would that mean? Do they care about each other? No, they don't give a shit about each other, right? So that means that they are independent. So this would be true if they were independent. If I ask you, are these two things independent? This is what you check, right? If I said, are events F and K independent, you would check maybe K given F, is it equal probability of K? If so, they're independent. If not, they're dependent. I really want that to make sense. So if event F happens and the probability of K changes, doesn't that mean the probability of K depends on if F happened or not? Does that make sense? So again, we actually got a good word, math people. We don't name things well very often, right? But this actually makes sense. If F happens and the probability of K does not change, they're independent. I don't give a shit. F is like, I don't care what or K is like, I don't care you happen. You guys kind of with me? Okay. So that's what I mean by or is basically add, because it's got an adjustment that you almost always have to make. It's very specific situations where you don't have to, where it's zero, so you don't have to worry about it. And is basically multiply because there's an adjustment. Now, last time we saw a situation, if I do something without replacement, the next probability changes, remember? So if I have 20 chips in a bag and I take one out and I throw it away, how many are left in the bag? So the next probability is going to be out of 19. It's changed, correct? But if I put the thing back in, everything resets, right? So that would be independent. Then it wouldn't matter what I just did because I put it back in and I reset everything. It's not dependent on what I just did because you kind of forgot. It's just back in the bag. Does that make any sense? Okay. All right. So I just wanted to do a little review, throw some formulas up on the board, and I promised you last time, considering I spoke, promised me too, that I would shut the hell up a little bit. So what I want you to do, is you're gonna work together again, right? We're gonna do our little thing where you turn around and stuff. We're a little off kilter now that nobody sits here. There used to be people that sat here, right? Oh well. So I'll trust you guys to make it work. But everybody's gonna work in groups, yes? So one side says this side in class, and the other one is the practice one. So this is the one I'm gonna have an answer key on Monday. Don't worry about those sides. Do the one that says this side in class. When I'm done passing these out, if you need a calculator, then I'll give you one. Hang on, hold on. Yeah, just that first four there. So again, the side that says this side in class at the top. That's the one you're doing.